Hello everyone. In this video I'll be attempting to release hydrogen gas from the AlGa alloy I created in the first part. But before we get into that, I'd like to tell you a bit more about hydrogen. Now, as I'm sure you know, hydrogen is the lightest element on the periodic table, and it is also highly explosive. It was first discovered by English scientist Henry Cavendish in 1766, who called it inflammable air. However, it was only given a proper name in 1783 by Antoine Lavoisier, a French chemist who also discovered oxygen. Nowadays, hydrogen is used as a rocket propellant and also as a potential replacement for cars which run on fossil fuels. Okay, so moving on to the actually interesting part of the video, the reaction. Now, as a quick reminder from last time, the metal alloy I created, AlGa, can be reacted with water in order to release hydrogen gas. I believe we even saw this happening to a small extent last time, and well, this small success gave me a lot of hope that the reaction would work. Hopefully it's gonna work better, where I'm gonna just straight up pour the water onto the plate. Okay, here we go. I don't think it's working. No. I wonder why that is. Try to pour a little bit more on top of it. Well, I don't know why that isn't working, unfortunately. I'm very sorry. And it didn't work. I was quite disappointed at this, which is why I decided to repeat the experiment with a new plate. As I had noticed, this one had some small issues. Firstly, the plate was very thick, which made the reaction quite inefficient. The second problem of this experiment was an error on my part, as in between filming this part and the other one, a week had gone by, because of a school trip that happened at the time. I presume that because of this delay, all of the AlGa had time to react with oxygen and moisture in the air, which left me with basically just a plate of aluminium and some byproducts. For these very reasons, I decided to switch some things up in the second attempt. Firstly, I bought a metal plate which was a lot thinner than the previous one, as it was only 4 mm thick, which should have solved that issue. The second thing I changed was the amount of holes. This plate was a bit longer than the previous one, which is why I decided to drill 4 holes instead of 2 this time. I also used 20 grams of gallium instead of 10 grams, so that I could fill all of the holes. As a precaution, I attached some bottle caps with holes in them using some super glue in order to prevent the gallium from spilling. Lastly, I placed the whole thing in a plastic bag so that no air could get in and ruin the reaction. So let's see how that went. Okay, so before I begin the experiment, I'd like to just show you this plate. This is the second attempt of this experiment, so I hope it works this time. Alright, so that didn't work out as well. To be honest with you, I have no idea why it didn't work the second time, as I had done everything pretty much the same way like first time round. The only problem I discovered this time was that because of the cold temperature outside, the gallium had a hard time remaining liquid. I didn't really believe this to be that much of an issue, as I had found a method of fixing that. By that I mean I placed the whole plate in an oven after I had preheated it. I presume that this was the main problem of this experiment. However, another hypothesis is that I just suck at chemistry, which is definitely a possibility. I had a small amount of hope that the bottle, which produced the bubbling sounds last time, still had some hydrogen in it, so that I could at least show you all something interesting. Unfortunately, as you can see in the video, it appears to have been all aired out. If I ever were to come back to this experiment and change some stuff, I would use some sort of acid, for example hydrochloric acid, which could be used to remove the oxide layer of the aluminium more efficiently. Other than that, there really isn't much more to say, so yeah, sorry, that's it, bye.